Hello Andre, this is Jack Crane with my video 5. Gonna be getting into terrain. Um, so starting with the age class, this was definitely the hardest part of the entire quarter. It took me way too long to get the entirety of this working. Barycentric being the most excruciating part of that. Iterator definitely took me my fair time, but once I figured it out, it made a lot more sense to me. Um, so for the constructor, I'm just taking a height map. Um, the length of the cells, the max height of the model map, the Y trans, the Y trans, so just um, basically the floor, um, where the floor will be um, for the model. Um, the UVs for the texture, repeating textures, the texture of the texture you want to put on the model, the shader object for whichever terrain. I believe it's texture flat. I'll have to check. And then the shader object, which will usually be for the shader object for the wireframe. Sorry. Then I just have a render render method, a set max min method, um, a terrain cell method, and instead of I in order to keep track of the mins and maxes of all the cells, I created an array of T cell structs, which are just structs with min and max values as well as a color. But I don't think I ever used the color. I probably should have taken that out, but I just left it in for simplicity's sake after making it. I thought it might be useful, but it never came up. Um, so this just returns the T cell at that position, usually when iterating over the array and iterating over the array using I and J or row and column, and I'm able to get the min and max from that to create AAVBs. This get cell add function is what gets the cell directly under whatever game object. Getting the object rectangle gets the uh, rectangle under the game object or the square or whatever, basically by computing the AVB of the object and then getting the cells from under that using the get cell add function. Show cells in min-max range used to be this. The get object rectangle uses the cell iterator and the new terrain rectangle class. This was the old one that before implementing the cell iterator created the cells under the object, the game object. Texel index and cell index are used to. It's just these functions. I'll go down to them. It's just multiplying by 3 using the row column and the side, and then the cell index to get the index of the array using the row column and the side. And then this get cell from index is basically just the cell index function, but calling to get the cell at whatever index is passed in. It just these functions just get the index in the array that is required. And I'll go back to the header file. And I have my get barycentric vector function and a get half point vect function, which returns the half point of the terrain. I was using this before because I wanted to center my terrain in the middle of the map. Unfortunately, that was causing me problems with the iterator, where it would be a little bit off underneath the whatever game object it was trying to show the rectangle of below, or what cells it was covering. It was hovering over. So I ended up scrapping it and basically just using this as a way to retrieve the half point of the terrain and then use that to manually drop objects into the middle. And then I have lots of data, lots and lots and lots of data to help me um, create the terrain. The number of cells, the width of the cells, the cell index, image height, image width for the height map, pixel length, which I set to, I believe, I'll just show it because I can't remember off the top of my head, but it's something divided by 2, I believe. Oh no, sorry, it's it's side minus 1 multiplied by the length. I apologize. The other one I was thinking of was the half point, image width divided by 2 times the length, but this is the side minus 1 times length, or the image height minus 1 times length. And I have obviously column max, column min, row max, and row min. These are 4 values that are very important to determine and they're important for the cell iterator because I need to pass those values in to determine the rectangle underneath the game object. And then I have a model pointer, a T-cell pointer for my structure array of structs, collision ABB pointer, which I use to create the ABBs for each of the cells, a terrain graphic object, as well as a wireframe graphic object. Wireframe helped a lot with debugging, and the terrain obviously is just the normal model. And then I have a vector of array normals. I have a vector pointer of array normals. I have a vector pointer norm array, which is just a pointer to an array of normals that I use to calculate barycentric. The anchor point, it just keeps track of the cell at the 0 position and uses that to calculate the rest of the cells basically and keep track of their position in the array. And then these are just values to keep track of offset that I don't actually think I ended up using, and a half point vector, which I use for the half point vect. And then this compute cell data function, which obviously computes the cell data. So we'll start from the top. When we get the terrain, we read it in the height file, set the cell width to length. This offset I don't end up using, and this half point vector I just initialize to 0 to not have it be garbage value at the start. Basically, I set the half point for getting the middle of the terrain by just taking the width of it, dividing by 2, and multiplying it by the length. Setting the side to image height because that's what side is. Setting up pixel length, and then setting up my number of tries by taking the side minus 1, multiplying by the side minus 1 times 2. And then I set up a index of tries and I think, are these arrays? I think they might be arrays. I think these are arrays of verts and tries. Yeah. Sorry, I'm just blanking out. I haven't slept in a while. I'm very sorry. Yeah, so I calculate the number of verts by just multiplying the side by the side, and I calculate the number of cells by dividing the number of tries by 2, and then I create a T-cell array with that number of cells and a normal array with the number of verts. So here I set my vertices by just going through the row and the column and getting the image data at the index using the side and the row and the column, and then I pass in, but I initialize the height value to this, and then I set height value to height value divided by 255 times the max height. Sorry, I'm like shaking my head just to keep myself awake. Then I use the incremented index, or I use the index starting at 0 to set each one of the vertices using this equation, which I'm sure we've seen millions of times by now. I know I have. I set up the anchor point to the first index in the list, and that's where it remains as a reference to set up the rest of the terrain. And then I reset my index to 0 as well as my cell index, because now we need both of them at 0 to start over and create the tries. I set my winding here. Then I create my winding values, and then I set my winding here on the list of tries. And then if after this check, I set up my all my int values for the center, down, up, right, and left vectors, as well as the right normal, as well as the top right normal and the bottom left normal. Then I set up the vectors using those values, and then I do cross products to get the normals, the normal vectors, the vector normals. Sorry. And then I get the sum of the vector normals to normalize that and set the pvert at the center to equal the sum of the vector normals respectively for each of the vector x, y, and z's. And then I set the normal array center to the sum of the vector normals, which I get by the reason I multiply by -1 here is because if I don't, I have a weird winding in a way such that my entire terrain is upside down if I don't do this. Originally, I had a different winding to attempt barycentric, but I was unable to get it any smoother than basically just ridiculous rocking. And Zach had approached me saying that he got it to work this way, or at least got it closer to working this way, as opposed to the direction I was going. So I tried to match his winding just to get the barycentric to a point where I could hug the terrain without it being ridiculous, in order to get my demo working. Yeah, barycentric was very tough for me, and if it wasn't for a lot of help from friends, I definitely don't think I would have had it implemented, because the version I had working, quote unquote working, with my winding was it would hug the terrain, but it was so bouncy, it wasn't playable. So if I didn't do it this way, I don't think I would have had it in time. So if this check is not true, otherwise I just use this else statement to set the sum of the vector normals to just the 0, 1, 0 vector, and I set the center to the whatever the current vert happens to be. I get the normal of the sum of the vector normals, and then set up the pverts setter index, normal x, normal y, normal z accordingly, and then do the same as above. And after that, I compute the cell data using the T cell at the cell index, whatever that may be, setting up the pverts for the top left, bottom left, top right, bottom right, and then pass all these values in as well for this compute cell data function, which I use to get the min point and the max point, as well as pass or set these values taken from my cell. Oh, that's right. I'm so sorry. In the T cell struct, instead of only having the min and max point, I added the top left, top right, bottom left, and bottom right values to each cell. This is probably too much, to be honest, but this is the way I got it to work, so I stuck with it. it's probably too much per cell because it's a lot of data to be iterating over and using. This is the get cell add function, which just gets the single cell. I'll take in a vector, subtract it from the anchor point, and then use that position um, to divide by the cell width and get the row column of this position. And then I use this row column to set the cell index and return the cell index, and then using that I can get whatever cell I want from the array. Getting the object rectangle, I'm setting the min max the min and max for both row and column, and I'm passing these ints in by reference to change them directly. So when this is called, through the terrain rectangle area, I can just pass in the imin, imax, and jmin, jmax values that this class stores directly in there. I set those by reference, and now these values are set in the rectangle, and I can use that rectangle object later. This was the show cells in max range, which was the way I was doing it before. I had the terrain rectangle area. This method still works, but I don't think I use it in this project anymore. And then I have the intersect method for terrain, which also took me a while to figure out, but not as long as barycentric did, that's for sure. So I go through the row min and row max and the column min and column max. I'm sorry, I'm just looking. Okay, so yeah, I was just looking to see where those set max and min values, or those min and max values were set, but I use a set max min to set them usually to the extreme ends of either negative or positive values, and then I'm able to call min and max functions on them to get to the values that I want from there. But in the intersect function, I'm getting the cell index by subtracting side minus 1, or passing in, multiplying j times side minus 1 times, or plus I or times I can't remember off the top of my head right now, but that gives me the cell index. And then using that cell index, I call set corner max on the CABB using the T-cell structure at this position in the index and getting the max point and the min point, and then computing the data using those. And then I call intersect between the CABB and a B-sphere. If that hits, then I call it between the collidable and the CABB, whatever collidable that may be. And then I just use these visualization functions to show the ABB and the collision volume and set it to green if they are if the B-sphere is touching, and if the B-sphere is touching, then I believe this is to check if they do not intersect, but the B-sphere and the ABB do intersect, whatever the collidable is. And then this is just to show if neither of them intersect, but it's still hovering over it. This was my original plan for the cell index color, but I honestly, it's really inefficient, and this is way better. There's no reason to store the color in the T-cell array, but I'm officially out of time. This is 7:30, so it will not be changed at this moment. And then I have the barycentric vector function, which gets the barycentric normal. And I'm fairly certain, well, in fact, I am certain I'm doing this wrong, but this was the closest I could get to making it playable. I get the top right norm, the top left norm. I get all the norms for the ABB, or the cell. Sorry, not the ABB. I get all the norms for the cell to um, to help with determining my winding. Um, and I set the clamp bounds to the object position. This was a attempt to clamp off the edges of the terrain, and it worked for all except, I believe, one wall that still crashes if I go outside. And I think other people had this problem as well, but I couldn't figure out a fix for it. I thought just clamping the Z and X values would help me, since Y isn't important, and I never have a problem flying off the map in the up direction. It's just I couldn't figure out how to clamp one of the walls. So this then I use this value to hold the clamping changes and also to work in cell space, and then I set clamp bounds x to clamp bounds.x minus the temp x, which officially puts me in cell space, and then I do an if check to see if the clamp bounds.x is greater than the clamp bounds.z. If that is so, then we're using the upper triangle, and if we're using the upper triangle, this would be the calculation according to my winding, or at least that's what I thought. But I'm not entirely sure. I think there was either my two main concerns, which was what I was messing with the most while working on this, was either these equations are incorrect and I'm not doing the math at all correctly according to my winding, or the way I'm setting up my verts is incorrect, and because the verts are aligned to the wrong, or the tries are aligned to the wrong triangle, or they're aligned on the wrong side. It's making it bumpy, but I wasn't sure. And then obviously this is the bottom triangle calculation, and then I return the very normal to whatever object needs it. And yeah, that's the terrain model class. And then I have a terrain object class that I used as a wrapper class for an asset. Originally I had this because I knew that the terrain couldn't be drawable, so my fix to that was to make a terrain object wrapper class that was drawable, but eventually I just got rid of drawable altogether. This became a wrapper class that functioned as an easier, less cluttered management class that the object manager could handle, and then this turned into my asset class as well. So yeah, this just has a constructor that passes it directly to the model, a draw, get terrain that returns the terrain, and this is used for scene changing and stuff like that. This get terrain middle was supposed to get the middle of the terrain, which just returns the half point vector. I don't know if I use this as often as I would have liked, but and then I can get the height from the vector. So the plan was to get the terrain middle and then call the get height function on that vector to return the y position. Didn't end up working out like I wanted it to, but I'm able to get the height from the terrain at any vector on the terrain. And then in the terrain object manager, it works very similarly to a lot of the other asset managers. Again, used a map for the simple purpose of being able to apply a key to a map, or a key to an object, and then recall it in that way. So I have my create terrain function. Check if I'm not using the resources multiple times. Otherwise, create the terrain. And then in my set terrain, I check to make sure that the terrain is not in the collection. If it's not, the p-terrain returns null pointer, and there is no terrain for the scene. Otherwise, just return the second part of the terrain. And I have a private delete function, which just iterates over the collection and calls delete on the secondary. object, which would be the terrain object in that key pair mapping. In my private process, I'm just checking to make sure that the p-terrain isn't null pointer, and if it's not null pointer, I call draw, and this is important for scene switching, because if I switch to a scene that doesn't have terrain, and I don't check for this, it will error out, because it's trying to call draw on something that's not there. And then this clear terrain does a similar thing, but it clears the terrain in the case that if there isn't a terrain and there's no terrain to clear, if there is a terrain, then I need to clear it so I can switch scenes and instantiate a new one, or not. Yeah, I believe that covered most of terrain, if not all of it. Oh, I have this terrain rectangle area, which I explained earlier, as well as the terrain iterator here. So this terrain iterator is used for the terrain collision test, which I will go into soon. We have an operator equals to compare the iterators against each other, as well as what it means to be equal and not equal, as well as what it means to increment. You increment the row and column, or INJ, depending on these checks here. And you set the current cell to the INJ to get an index in the T cell array. And then in the terrain iterator constructor, I pass in the current I, current j, as well as the min I, the max of that I, the min of that j, and the max of that j. And then I set all of those values to be used later in the terrain the terrain command test. Yes. Before I go into that, I'll go into the test and then I'll demo the terrain. So this is my collision test terrain command. I have a collision value CABB, as well as just a generic collision volume pointer. In the constructor, I just get the collidable groups collider collection, which I think just gets it gets the collection of collidables for this entire group. It has a reset function that I don't use, as well as a execute function. The execute function does obviously all of the intersect checks. So we start by creating a temporary rectangle and setting it to the terrain rectangle of the iterator. Now we go into the first for loop that uses that sets the iterator to the beginning of the rectangle cells. So instead of going over the entire terrain model, we're only going over the terrain cells that are inside the square below the object, which is what the collidable collection is. So we start at the beginning, go to the end. Then we compute the data for the CABB by getting the cell's min point, max point, which gives us a CABB for that cell. Then if that CABB intersects with the iterator's B-sphere, we can go deeper and do a check with the CABB against the iterator's actual collision volume, whether it be OBB, ABB, or if it's just B-sphere, then we're good to go. But if we need to go deeper, we can. And then we do visualizer shows to show that. And now I will go into the demo to show my terrain. So this is the terrain. As you can see, I have barycentric working. That ray pointing up from the normal of the tank is the visualizer show ray. Oh, I don't have. I don't have the. Okay, here we go. Do yeah, I don't seem to have the iterator showing in that test, so here you can see that I have the square below the I have the cell square below the tank, and you can see that the B sphere is hitting it in some cases, and the red squares are representative of the actual collision volume hitting it, and sometimes it has a problem with the order of the draw, just because there's the cell length is very large, so it's calling both at the same time and is having trouble deciding which one to show. But I believe they're just both getting called. I could show. I could make the cells smaller to show otherwise, but in fact I'll just do that. But this will show just how bumpy my barycentric actually is. Little resources. I know this is taking long. I apologize. I probably should have split this up into two. Resources, little resources. I can make these the size smaller. Just go down to something like 10. And this is going to show just how bumpy my barycentric function actually is, and how bad my winding or my board setup is. Oh, is that outside the range? Wait a minute. Try 15. It might be outside the range of the TGA. Had that problem before. Oh, yeah. It's because I hard-coded all of my values for the demo, unfortunately, so I won't be able to show a smaller version. Well, that's unfortunate. Hopefully that doesn't kill my grade too much. Goddamn, this has been a really rough quarter, I tell you what. Anyway, that's the cell iterator. I believe I covered most of terrain, and hopefully the end of that video doesn't screw me over too much. I believe I just have the demo and sprite fonts to show you next, so after that, it's going to be over. Thank you.